Hey there! Today, we are going to tackle a classic algebra puzzle, solving exponential equations. Now, I know they can look a little intimidating at first, but trust me, by the end of this, you'll see they all follow one simple, really powerful rule that makes them totally beatable. All right, let's jump in. So, take a look at this. You've got variables up in the exponents. The main numbers, the bases, a 9 and a 27, they don't even match. I mean, where do you even start with something like that? It looks tough for sure, but stick with me, because we are going to break down the exact strategy to solve this and any others that look just like it.
So first things first, let's just get on the same page with our vocabulary. What we're dealing with here is called an exponential equation. And it's really simple. It's just any equation where the variable you're trying to find, usually x, is hanging out up in the exponent. That's it. Now this is the secret key to everything we're doing today. You can call it the property of equality for exponential equations, but I just call it the golden rule. And what it means is actually incredibly simple. If you can get the bases on both sides of the equal sign to be the same number, then you can literally just ignore them. You just set the exponents equal to each other and solve that. This single idea is going to solve every problem we look at. Okay, so to see this rule in action, let's start with the easiest possible case, right? What happens when the bases are already the same? Let's check out this first example. We've got 3 to the power of x plus 1 equals 3 to the power of 5. The base on the left is 3, and the base on the right is 3. They match. This is the dream scenario, and it lets us use our golden rule right away. And look how easy this makes it. Since the bases are both 3, we just kind of forget about them. That complicated-looking exponential thing just turns into a super simple equation. X plus 1 equals 5. You subtract 1 from both sides, and there's our answer. X equals 4. See? The rule just does all the heavy lifting for you. Okay, so your turn for a second. Look at this equation. You've got a base of 5 on both sides. So using that golden rule we just talked about, what's the very first move you'd make here? Yep, that's it. You just set the exponents equal to each other. 2x equals x plus 1. And you're already halfway to solving it. All right, that was a good warm-up. Now, let's get back to the real puzzle, the kind of problem we started with, where the bases don't match. This is where the fun really starts. Let's go back to that original problem. We had a 9 and a 27. They're not the same, but the secret isn't that they are the same. It's that they can be made the same. So think about it for a sec. What do 9 and 27 have in common? What smaller number connects them? Exactly, they are both powers of 3. 9 is just 3 squared, and 27 is 3 cubed. And this insight right here, this is the aha moment. It's the one creative step you have to take that unlocks the entire problem, finding that common base. So let's put it all together. We swap out the 9 for 3 squared, and the 27 for 3 cubed. Now for step 2, we have to use a rule called the power of a power property. It sounds fancy, but all it means is when you have an exponent raised to another exponent, you just multiply them. So the 2 gets multiplied by the x plus 2, and the 3 gets multiplied by the x. And what do you look at that? Suddenly we have the same base, 3, on both sides. Now we're on easy street. We drop the bases, set the exponents equal, solve the simple little equation that's left, and we find that x equals 4. Okay, let's do one more like that just to make sure it really sinks in. We've got 4 to the power of x equals 2 to the power of x minus 3. Once again, the bases are different. We have a 4 and a 2, but can we find a common base? Of course we can. 4 is just 2 squared. So we rewrite the left side of the equation. Then, just like last time, we use that power of a power rule and multiply the exponents. 2 times x gives us 2x. And just like that, both sides have a base of 2. So we use our golden rule, set the exponents equal to each other, and solve it out to find that x equals negative 3. See? The pattern is the exact same every time. All right, for our final challenge, let's look at equations that have fractions in them. Now, these might look like a totally different beast, but you're about to see that our golden rule is strong enough to handle these too. So what about this one? 1/2 to the power of x equals 4. A fraction and a whole number. How on earth could we find a common base between 1/2 and 4? Well, the trick here is just to remember what negative exponents do. And there it is. The fraction 1/2 is just another way of writing 2 to the power of negative 1. And, of course, 4 is just 2 squared. So we rewrite both sides with a nice clean base of 2. We use that power of a power rule one last time, multiply -1 by x to get -x. And from there, the steps are exactly the same as before. Drop the bases, solve for x, and we find our solution is -2. It always comes back to that same core idea.
So let's just boil this all down. This is the strategy, the game plan. No matter what the problem looks like, your number one goal is to make the bases the same. You usually do that by rewriting bigger numbers or fractions as powers of some smaller common base. Once you get them to match, you just set the exponents equal to each other and solve whatever simple equation is left over. That's the whole game.
You know, we started with a problem that looked pretty messy, but it turned out that one single rule was the key to unlocking not just that one, but every single problem we looked at today. And now, you have that key. So the only question left is, what other exponential puzzles are you ready to go unlock?